on the first one, all you're gonna do here in this first one, you're gonna use the graph, answer the question. So with this one, all we're doing is we're just learning to looking at how to interpret this graph. So it says which statement is true, and you're looking at just asking about your slopes and your y-intercepts. Okay, just looking at that, seeing which one of those is true. Whoa, whoops.
What did you say?
We're just looking at this graph and determine which one of those statements is true.
Is this talking about when it says y-intercept?
Your y-intercept is where it's going to cross the y-axis. So if I look at the y-axis here, okay, I can see that both these points have crossed at the same point, so that both those lines would have the same exact y-intercept. At which point represents a solution to the system. So when we have points, and some of you may think this is repetitive, but your point is x comma y. So when I have a point, I'm going to start with this x-axis. All right, so my point's here. Okay, so you're going to go over. However many you go over is your x-coordinate. How many you go up is going to be your y-coordinate. Okay, so what is that coordinate? Another way to think about that, let's say you have trouble reading coordinates. Okay, if you think about a coordinate grid, every point up here is a positive positive. Points over here are negative positive. Down here are whoops. These are negative negative, and over here these are positive negative. Okay, so if my point is up here in this second quadrant, that point needs to be a negative positive. So that can eliminate B and C for you. So now you just have to determine which one it is there, A or D. Look at the system of equations below. So we have our system here, and which one of those graphs represents those systems. So if you pull up your Desmos, you can plug that in, and you'll be able to determine which one of those is the system. So again, for your Desmos, if you just go to the website, click on calculator, and then math tool, go to graph and calculator. We're going to go next one. Okay, which graph represents the systems of equations below? Again, plug it into your Desmos, and it'll give you that answer. Now, if we remember, if we look at slope, we can eliminate C and D because these two have different slopes, which means they're not parallel.
What's eliminating? Sorry,
What is it again?
what can you eliminate?
You can eliminate C and D because those lines are not parallel. They don't have the same slope. Am I good? 5, what is the solution to the system of equations shown above? Now again, here, you can use substitution if you want to, okay? If you don't understand substitution, remember, you can always use what? You can always use a Desmos, okay? You can always use a graphing method, plug it in, wherever those two equations intersect, that's going to be your solution. Yeah. Oh, the whole thing's right.
Every time I go to the calculator, and like, you can move everything.
No. Stupid.
It's very simple. Sorry. Yeah.
Yeah, you're
So smart, don't know it.
What are you looking for?
Don't know it.
Yep. So like here, if you see it's wider than here, it's closer to here. Just scroll it down.
You got lowest first or above first?
Like if you click on the point, it'll tell you what it is. You click one of those lines, that will show up. Then you hover over it. Just click. You should see a little gray dot. Yep. We good? Everybody ready? Okay, you good? Okay. So 6 says use substitution. Obviously, you don't have to use substitution. Okay. But find the solution to that system. And just FYI, don't just plug in a Desmos and think it's right. Double check your equations, make sure you type them in correctly. Okay? Because I've had that before. Well, I typed it in here. Yeah, but you typed it wrong. Oh. Okay, that makes sense. So it's my fault. It's my type wrong. So it's pouring down rain, now the sun's coming out. That's so weird. Go to the next one. So look at the system of equations below. Which statement is correct? So if we look at these, okay, what do we notice about those two equations? Do we notice anything about them?
There's 2 tens.
Well, that bottom one's not a 10. What type of 10 is it?
Negative.
Negative 10.
There's two, 2/3.
2/3. All right, so that number in front of x is what? We have slope intercept form. So that number's right next to x. What does that represent? If everybody looks to the left, it tells you.
We'll know what we're looking at.
Slope intercept form. What's that number in front of x represent? Slope. So they have the same slope. What do we know about lines that have the same slope? The what? What do we know about parallel lines? Do parallel lines ever touch? They don't, right? They're like railroad tracks, they never touch. So how many solutions will it have?
None. They don't touch either. Yeah, I already typed in the
I'll say no more. You typed in the Desmos for real?
Yeah, I was trying to find where it was gonna be connected.
Parallel lines, same slope, they will never touch. So if lines have the same exact slope, they have no solution. Okay, number 8, Desmos. What are the coordinates for the intersection? Type those in, it'll give you your intersection points.
Did you put this in right?
Huh?
Did you put this in right?
Did this get typed in right?
Well,
Well,
type
this,
to the top one.
all right.
Mhm.
Then it gives you a line.
Yeah.
Then you type in the second one. And then it gives you your intersection point. Remember on your fractions, like 1/2 x minus 2, when you type that in, you have to hit that over button, or it's going to be really weird. Okay, y equals, we'll hit 1/2. I have to hit over, put x here. If you don't, it's going to put your x down here, and then you're going to get sine, cosine, and all that good function stuff. So make sure you hit over to x over there. We good for now? The system of equations below shows the rental cost y in dollars for renting a kayak for X amount of hours from 2 different rental companies. What number of hours the rental costs be the same for both? Now, I talked about this the other day in class. You have your XY coordinates. Okay, that's going to be your solution, right? You plot those where they intersect. Your solution is a point. It's XY. X. What does X represent in this system? Hours. So my X is hours. My Y represents my cost, my dollars. Okay. So when you get a point, say you get a coordinate point, I'm just making this up, say 8:35. Okay. What's that 8 represent? This would mean 8 hours for $35. Okay. So yes, that solution is a coordinate point, but also represents something. So when our question says for what number of hours will the rental cost be the same? When you plug those into your Desmos and you get that solution, okay, the X or the Y, which is the point that you want? It's asking us for cost. So when I get that solution, when I get that intersection point, it says your intersection is 2, 5. Which one of those coordinates is the one that I'm looking for my answer? I'm looking for Y. So when you plug that in and you get your intersection point, your Y value is what's going to be your answer there. Everybody good? Go to the next one?
I typed it in, but they never called.
They should.
Yeah, I typed it in.
Yeah, you may have to zoom in and scroll around and find it because we're dealing with large numbers, okay? It's gonna means your graph is gonna be really, really big, all right? Domain and range of G, a function, are shown on the table below. With this type of question, what's gonna throw you guys off is this right here, okay? Remember we talked about functions. Our function symbol looks like this, f of x, okay? It can also be just like this, g of x. But if you have a variable with parentheses and an x inside, basically it's the same thing as just having y, okay? So when we're writing this equation, I know we have y equals mx plus b, but in this instance, it's going to be g of x equals mx plus b, okay? So we're looking at the function. With our function, the slope-intercept form, if we look at slope-intercept form, what are the two things I need to write something in slope-intercept form? I need a y-intercept, and I need a slope. That's right. We need y-intercept and slope. What happens at the y-intercept? What's important to know at the y-intercept? What happens with my coordinates? What happens at the y-intercept? And then I got an x and a y coordinate. So what happens with my coordinates? X equals 0. X will always equal 0 at the y-intercept. So look at my x values. X equals 0 right here, which means my y-intercept is what?
0?
No. If x is 0, what's y? I mean, it's funny, but it's not at the same time. It's like right there, guys.
-3?
Yes.
So smart.
Y is -3. So my y-intercept is -3. That's all I have to do. Because my answer's there. I don't have to do anything else. So look at your answers and see which one has y-intercept of -3.
It's pretty great. No, it's just a test. Oh, God. We're gonna reset mine.
I hope not.
Already know.
Which graph represents solution of the system below? So again here, plug this into Desmos. $12. The only coins that Alexis has are dimes and quarters. Her coins have a total value of $5.80. She has a total of 40 coins. Which of the following system of equations can be used to find the number of dimes and the number of quarters Alexis has? This is writing the system from a word problem. We didn't go over this because this is one thing that I think that we should just skip. All right, this is really difficult to do, especially for like my algebra and geometry kids. So I'll give you the answer here. This is going to be, let's see, no, not that one. Be D. So this one's D. So number 12 is D.
You should have one that like the right. Oh, it's got two just right.
Okay, so the graph below shows rental cars rates. Now this is another question. If we look, it says, if we skip us and read, it says how many miles would cost same to rent each vehicle. We're not going to have an X, Y, okay? So when I have my X and Y here, we need to read the question and figure out what's X going to represent, what's Y going to represent. So if I look at my graph, all right, my X axis represents what? Miles. So my X coordinate will represent miles. My Y coordinate will represent cost. Okay? So here's where they intersect. It's asking us how many miles will the cost be the same to rent either vehicle? Is it asking us for miles or is it asking us for cost? It's asking us for miles. How many miles will the cost be the same? So you find that intersection point, you determine which one is miles.
Why are these tests so long?
This is a test.
Yeah, I mean,
Well, the more questions you have, the
I
better.
mean, you can do it on your own if you want. I'll shut up.
No.
Okay. Which of the following tables does not represent a function? So remember, if something's a function, which coordinate cannot repeat if something is a function? X or Y?
What?
So we're talking about functions. All right. Which coordinate cannot repeat if it is a function?
You can't repeat, right?
Which one? X or Y?
X.
X. If X repeats, it's not a function, okay? So it's asking us which one does not represent a function. So A, B, C, or D, which one of those has X values that repeat? They will repeat, and that is your answer because it means it's not a function.
Trying to tell you. I was on the whole other problem.
What problem?
I was on the other problem. Can you say that again? About this one?
If X repeats, it's not a function. So it's asking us which one is not a function. So you're looking for which one of those has an X value that repeats. Okay, so Becky created the line, the graph shown distance she traveled during one day. Which activity represented by the circled portion of the line? So here, remember, when we start time and distance graphs, time always moves, okay? Which means once this graph starts, it'll always move in this direction, okay? Your distance is determined on how far away you are from your original starting point. So this point here that's flat, all right, that means that, what's her name, Becky, didn't get any further away from her original point, but time was still moving. So what could this represent, okay? With A, B, C, or D? Remember, time is still moving, but according to this, Becky is not, because she is still the same distance from wherever it was that she started, all right? So if she's driving, she's getting farther away, so it can't be that, all right? So which one of those would represent that line? What you typing? What you typing? We don't need to type on this.
I was trying to finish. I was texting my teacher.
Why? But you're in my class. Come on, man. What's the slope of the line that passes through those points? So if you turn your heads to the left, there's something over there that says slope formula. And it shows you the formula. I will give you a hint on that formula. Take these points, I will label them. And then all you do is you plug those in and you solve. Okay? So we get y2 minus y1 over x2 minus x1. What's y2? Which one of those I'll label as y2? 2 minus, which one is y1?
3.
Negative 3. Which one's x2? 4 minus what's x1? 1. If you struggle with subtracting negatives, I would plug it in the calculator or you'll get it wrong. That's all you do, that'll give you your solution.
It's a lot easier than that.
With this?
Yeah.
This problem right here?
Yeah.
Yeah, it is. It's that easy, I promise. You just,
Swear.
I mean, it like, even with this, they don't have to be this. I can have them like this if I want to. X2, Y2, X1, Y1. The only thing that you have to make sure when you label is, are my ones together or my twos together? So I can't go X2, Y1, X1, Y2 and be completely wrong. All you just label, put it where it goes, and go from there.
So does X always have to be first?
Well, it's just like a coordinate point. You have X, Y. So that's why your X will always be first. Am I good? So I hit this mouse, it goes away. I wish it would stay, but it don't. Solve the equation. We've been doing equations. Y'all should have this locked up for sure. So remember, with an equation, there's 4 different ways you can start this. Okay? And I don't care which way you start it. You make math, however you understand it, do it that way. Okay? Now my mind works. I'm thinking I'm going to get this variable to the left because I want the variable on the left. To move something in an equation from side to side, how do I move that from here to here? What has to happen? You have to do what?
You have to take it off both sides.
Yeah, but how do I do that though? You could do that, yeah. So if you're subtracting 12, that's a positive 12. You subtract 12, positives and negatives are, what do they call it? It starts with an O. Like positive and negatives are what? Opposites. Anytime you cross this line, you have to be opposite. It don't matter what I move. If I do the opposite, I can move it from side to side. Okay. So you said you want a minus 12. Okay. Well, if we minus 12, we can do that as long as we do the opposite. And you're going to have 4x minus 15 equals x. Then you have to get your variable on the same side. Okay. So the variable is what some people struggle with moving because we just want to move it. But this is an x, but what would you do, say, if that was a 3? How would you move that 3? Just like you move that 12. But it's an x, okay? It's a positive x. Opposite of positive is negative. Okay, yes?
If you did it from the beginning, couldn't you divide 4?
You can, but here's why I wouldn't, all right? Let's say you want to divide 4, okay? Now, when we minus 12, we just minus 12 minus 12. But if you use multiplication and division, you have to divide 4, divide 4, divide 4, divide 4. It's going to get messy. Because now you got a fraction here. This will be a fraction. That'll actually be a whole number, but it's going to get real messy. But you can, but it creates a lot of fractions. But now what I would do, me personally, I would go ahead and move that variable because if you look like if you minus 12, you have 4x minus 15 equals x. Well, then you're going to have to subtract 4x, negative 15 equals negative 3x. And that's fine. Me, that would drive me nuts because I don't want the variable on the right. I just don't. But it's all personal preference, okay? I would subtract x because I want to get the variable on one side so I don't have to worry about it anymore. That'll give me 3x minus 3 equals 12. And now you have a two-step equation. So what do you do first in a two-step equation? What do I get rid of first? Because remember, at the end of the day, I want the x by itself on one side.
Did you get rid of the number that's with x?
Not yet. That's what's confusing because with order of operations all your lives, you all have been taught parentheses, exponents, multiplication, division, then addition, subtraction. With two-step equations, we get rid of addition and subtraction first. That's the first thing we get rid of. Okay, so I'm going to leave that 3x alone because, like I showed you a second ago, if you divide by 3, you have to divide everything by 3. So you could, but like again, it would get messy. This instance, it would actually be everything be even, but it never happens like that. So I would add 3 to both sides and then divide. Go. Or if you're really lost, you can always guess and check. Try to get an answer from A, B, C, or D and see if you can get both sides to equal each other. It's always another way to do it. Everybody good? Any more time? '18. Regina's piano teacher kept this record of Regina's progress on a song she's memorizing. How many days of practice did it take for Regina to memorize half the song? So we're looking at days. Okay. How many days did she practice total? 12. We know that because it's right on our graph. What's half of 12? 6. If you go to 6, how many days did it take for Regina to memorize half the song? Oh, I'm sorry, I'm saying that backwards. My bad. Look at percent memorized. Okay. It goes to what? 100%. What's half of 100? 50. Because 50 is your halfway point. How many days is 50 at? That's a rhetorical question, Sean. Which of the following expressions is equivalent to 6xy raised to the second power? So this is product to a power rule. And if you look to your left, it tells you how to do that. Product to a power, this is like distributive property. Everything on the outside times everything on the inside. But this is in reverse. If a number or a variable is by itself, what exponent is that raised to? They're by themselves, but to the what power? It can't be second because second's not up there. Like when I write a 12, I don't say, oh, this is 12 to the second power. It can't be to the 0 power because everything to 0 power is 1. Okay? If a number is by itself, it is always raised to the first power. Okay? So product to a power rule, this 2 is going to be multiplied to each of these. All right, so you're going to have 6 to the 1 times 2, x to the 1 times 2, y to the 1 times 2. And then that's going to be your final answer. So you multiply those exponents, and that will give you your answer. What's the slope of the line that passes through the points listed in the table below? So we can do this two ways. Okay. The first way is the way that Addison said was really easy. Now she understood it. We can do this. And you might say, well, I don't have 2 points. You pick 2. Okay. So if you look up here, this is a coordinate point. That's a coordinate point. Each one of these are coordinate points. You could pick 2, label them, plug them in. Okay. Or if you look over their slope is the change in y over the change in x. So if I do it like that, change in y over the change in x, I go through my y values. What did they change by as I went down? What did my x values change by as they went down? This is your y change, it's your x change. Plug them in there, and that'll give you your slope. Can I go on to the next one? Good? Good? Which of the following graph shows temperature decreasing over time? So temperature decreasing over time. Remember, you read graphs from left to right. Start on the left, go right. Which one of those graphs is decreasing over time? The y-intercept of that equation, remember y equals mx plus b. So which one of those is your y-intercept? And if you look to the left, that equation will help you. For some of you, it might help to actually write that right below this. If I did this, and I went all the way back to the top. Okay. If you actually write y equals mx plus b underneath of it, that'll probably help you out. Okay. The equation below is used to find x, y coordinates. Which one of these coordinates can be found using the equation above? So I've always told you guys go with the y-intercept. It's an easy way to start with things. It can help eliminate a lot of these problems. But we know that earlier, somebody, I don't remember who told us that the y-intercept on x is 0. Look at all my x values. I don't have a 0 for any x value, so I can't cheat and use my y-intercept, which that stinks. Okay, that's always an easy way to go about it. Okay, but if I look at my slope is 3. So remember with our slope, like we just did, you're changing y over, you're changing x. So if I look at all these, I can start with my y. That means that my slope is 3, so my y needs to change by 3, my x needs to change by 1. Okay? So let's look at A and see if my slope matches. That means I'm gonna have that adds 3, we're good. That changes by 1, we're good. B, y does not change by 3. So I can eliminate B. C, we're changing by 3 each time, 5 to 8, 8 to 11, changing by 1. And then D, I can eliminate D. Okay? So now I'm between A and C.
I think both right.
No. Well, they're both different. They can't be both right. So here's what you do. We know that all my coordinates here, if I go from here to here, I'm adding 3. Here to here, I'm adding 3. And on my x, I'm adding 1, I'm adding 1. All right? Can I get to a y-intercept? Which means, can I get to where my x is 0? I can do that, right? But I have to go the opposite direction. So if you take this and go the opposite direction, you need to -1, and here you have to -3. If you -1 and -3, which one of those is going to give you that y-intercept that you need? If you work backwards, okay? Which set contains an irrational number? Rational and irrational numbers, okay? My mind, I always look for the square roots. That's an easy way to find an irrational number. So we're looking for these 4 sets here, seeing which one of those has an irrational number, all right? Remember, a square root is only rational if that number inside of it is a perfect square. All right, so my perfect square is like 1's a perfect square because 1 times 1 is 1. 4 is a perfect square because 2 times 2 is 4. 9 is a perfect square because 3 times 3 is 9, and so on. All right. So if I look at these, I would go to the square roots and I would see which, if both those square roots work out. If one of them does not, that's going to give you your answer. And my last one, a farmer is planting a field shaped like a rectangle. So for these types of problems, a lot of you need to draw a picture because some of us do not do well at visualizing this. The length of the field is 1.65 times 10 squared. The width is 1.5 times 10 cubed. What's the area in square feet of the field? How do you find the area of a rectangle? How do you find the area of a rectangle? Length times width. So I'm doing length times width. I'm going to do 1.65 times 10 squared times 1.5 times 10 cubed. So we're multiplying scientific notation. Use your Desmos. Make sure